So, good day everyone. Today we will going to discuss the chapter 12, the gas loop from the book of Frederick T. Morse, Power Plant Engineering. So, the gas loop. So, function of the gas loop. The equipment considered as gas loop has the function of creating the proper conditions for combustion, of supplying the ingredients for combustion in proper proportions, in moving the products of combustion to the atmosphere. These actions necessarily involve the combustion equipment itself. So, for the examples, the furnace and burner or stoker. So, we just have to put in our mind that the gas loop has the function of creating proper conditions for combustion. So next, the illustration shows the figure shows the gas loop showing associated equipment. So the equipments are the storage fuel, the fuel conveyor, ash disposal, ash conveyor, live storage, fuel quantity, combustion control, duct, air heater, dust collector, fans, preaching, and the chimney. So, this equipment, the gas passages, the chimney, the arrangement for supplying fuel and air to the combustion equipment, and removing ash from it, together with the control and regulatory apparatus, are what constitute the gas loop. So, loop refer to gaseous flow connected with a steam power plant. So our next is the coal storage. So the coal storage is to place coal in storage can be as simple as dumping loads of it from motor trucks onto the ground in an area assigned a coal pile. So at many industrial and all utility plants, a mechanical system for receiving coal from the delivery system, conveying it to storage, holding it safely, then reclaiming it for use will have been provided. So, for the purpose of the fuel storage is twofold. So, there are two. So, the first one, fuel storage is insurance against complete shutdown of a plant. Normal operating supplies arrive. Second, storage permits some choice of the date of purchase. So, that's for the purpose of fuel storage. It has two. Next is the live storage. So, storage from which coal may be withdrawn to supply combustion equipment with little or no rehandling. So, this storage is the one that the coal may be withdrawn. So, dead storage is that holding area from which coal can be only be taken by exercise of a definite reclaiming and conveying activity. Dead storage is ordinarily an exposed pile laid directly on the ground. So exposure. So at some point maybe kumbaga sa open space. Next. So this figure shows the outline of coal handling equipment. So this these are the outline of coal handling equipment. So the best remedy known at the present is to exclude air from the pile by, so the following are the remedies. So firstly, underwater storage. Next is bituminous surface coatings, rolling and packing an airtight layer of fine coal on the surface coating. So next figure would be the storage and reclamation by drag scraper. So delivery by railroad may be 1. To truck hoppers at the ground level. 2. To unloading spore where locomotive crane unloads it with grab bucket. 3. To storage pile beneath elevated trestle. Or 4. To open dump at ground level. So handling to storage is generally one of the following methods. So the following are the methods. Number one, drag line scraper, so has the advantage of low first cost and maintenance, but large energy consumption per ton is disadvantage. Although, so for number one, low cost siya, pero but it has a disadvantage that it consumes large amount of energy. So next is the bridge crane, which is the flexible and of high capacity but requiring a heavy investment. So this one is expensive one. So third is the locomotive cranes, this both on rails and crawler treads. Flexible but usually higher cost than drag scrapes. Scrapers do not require formation of a stocking out as pile to drag scrapers. So this one also is an expensive one. So four is the bulldozers and industrial trucks. So the figure 12-4 shows the apron feather shown removing coal from a truck hopper and discharging it to a crusher. So this one is the truck, and this um from this truck, so it came all the way here to the crusher. So next, so live storage can be provided with bunkers, soil silos, and cold bins. So bunkers is used here to describe cold storage that is not a part of a building structure but rather which is separately constructed. So the most common from bunker is overhead suspension type, usually made of 6.3 millimeters plate steel. So it has a standard size or standard thickness of steel, and the vertical cylinder is usually mounted outside the plant building on the roof or its own separate structure. So next is the throw suspension bunkers are inside mounted. Burkist form approximate the ideal shape which would produce only tension in the steel and thus do away with stiffening structure except on the ends and interior bulkheads. So the next figure would be the forms of steel pole bunkers. So first we have here a cylindrical bunker. Next is the brace one. This is how it looks like. And the Burkis one, which is this one. So next would be the coal conveyors. So a conveying system must be installed to carry the coal from the delivery station to combustion equipment. So the coal movement is generally accomplished in three steps. There are three steps in accomplishing coal movement. So first is a hoist to be convenient elevation above live storage. Next, the horizontal transportation and dumping to live storage. And last is the gravity flow to the combustion equipment. So this figure shows the diagram of belt conveyor. So the following are the common examples of hoisting equipment are first bucket elevator, moderate lifts continuous operation, grab bucket with crane or tower, skip hoist, applicable when lifts are too high for bucket elevators, simple and compact, belt conveyors, which is shown above the above figure, limited to less than 20 degree to horizontal, therefore it is necessary to start considerable distance from the plant. Fifth is the electric hoist to elevate coal buggies which have been filled at the storage pile and wheeled into the plant. By hand, they will be hoisted until the contents may be discharged into the stoker hoppers. So these five should be remembered for common examples of hoisting equipments. Next would be the horizontal movement of coal to bunkers by conveyors, of which the following are typicals. First is the belt conveyors. So continuous system, belt usually through high capacities. So the belt conveyor should have a high capacity as possible. So second is the spiral conveyors. So this may be the types of conveyors. So endless helicoid screw in a trough can easily be made thus tight, not having a return stand, and it requires a minimum of space limited to land considerable wear. Third, flight or scraper conveyors, low in first cost, so it's cheaper, having large energy consumption, but the disadvantage is it consumes large amount of energy. There is considerable wear caused by friction and abrasion. 4 is the pivoted bucket carries, probably ideal for a good many standpoints, although expensive in first cost. So this one is expensive. Material is carried and buckets are supported in rollers which reduce friction to a minimum. 5 is the Larry's suspended rail types are generally used because even though they require more headroom than the floor type, they leave the boiler aisle free from obstructions. So this figure, the figure 12-8, this is the section through a through belt conveyor. It shows the section through a through belt conveyor. So the next one is the figure 12-10, which is the pivoted bucket conveyor combined coal and ash handling in a large plant. So this is how it looks like. Next is the trump iron. Trump iron is removed magnetically before coal is passed into pulverizers or crusher. So this one is the one that should be removed before the coal is delivered into before the coal is crushed or before the coal pulverized. Weighing coal can be incorporated into the conveying system. First, at truck scales. Second, by weigh Larry's. Third, by coal spout volumetric meters. And lastly, by scale stations between bunker and downspouts. Coal gates and spouts. Coal will readily flow by gravity through square or round obs, so it has a 30.5 centimeters internal dimensions. It has a standard dimension, provided the inclination is not too flat. So the inclination should not flat, or it's somewhat inclined but not that really low. If the spout's more than 30 degrees to the vertical, it should be arranged so that the operators may wrap it if the coal should lodge. Next, special designs are required on these distributing spouts in order to keep the coal sizes from segregating in them. So conveyor layout. So the conveyor layout, the design and detailing of mechanical conveyors are sufficiently specialized to lie outside the ordinary scope of power plant engineering, and the plant designer customarily relies on conveyor manufacturers for advice on layouts. So walkways need to be provided alongside conveyors for maintenance and inspection. So the conveyor layout must has the guide of the specialist. So it should be it should be customized also on the conveyor manufacturing, and it must an advice from experts. So belt conveyors, this type is probably more universally used than any other. So this one is the very common. So the reasonable and the power consumption is low. So it doesn't consume much. So it is widely used for horizontal movement of coal into a certain extent for inclined runs. So a fair average speed of all belt conveyors is so it has a standard speed which is 91.4 meters per minute. It is the usual range for coal conveyors because higher speed tend to shatter the coal. So this speed must be used so that to avoid some sh- some shattering of the coal. Both flat and top belt conveyors can handle coal, but the top one are more frequently used because their capacity is about 100% greater per inch width or belt